All right. Well, happy Thursday anyway. Happy Thursday. Tomorrow's Friday. One more week and one more day. We can make it. We can make it. So how do we do this? So first of all, we're going to expand it, meaning we're getting one log and we're separating it into two or more logs. And in most cases, with the properties we saw, it's two logs. So now, how do we know which one it is? Well, let's look at what we're finding the log of. We're finding log base 5 of 1 over 3. Well, 1 over 3 is a quotient, right? That's a division problem. So we go back and we look and we say, oh, which one has a quotient? Well, this is the product property. That's taking the log of a product. That's not what we're doing. Then we have the quotient property. We're taking the log of a quotient of a division problem, and that's exactly what we have. So we're taking the logs. That means we're going to use the quotient property, which states I can get this log and separate them into two logs, and we're going to subtract the logs. Remember, like we subtract the exponents. These are the exact exponent laws. These are the exact exponent laws, the exponent rules, exponent properties, but just in log form, because those of you that haven't been showing up to class, logs are just another way of saying exponent. When I say log, this is basically saying, what is the exponent of that base that gives me this result? Okay, so that's what it's asking. So we're not trying to find the answer right now. All we're doing is expanding. Kevin, you made it. Kevin, you need to take that STAR assessment. Thank you for joining us. You need to take that STAR assessment, and you need to turn in some work too. But yeah, take that STAR assessment, please, Kevin. Don't do it now. Pay attention to class now, but it will be open all day. So you can go to that Renaissance STAR assessment that I've been saying for days and days and days. So please work on that, Kevin. Thank you for showing up. All right, so how do we do this quotient property? If you forgot, let's go back. It basically says if I'm taking the log of a quotient, then I can get the log of this result and subtract the log of this result. Basically, we're doing this rule, right? We're doing this rule. If we have the same base, we just subtract the exponents, right? We subtract the logs, subtract the exponents. Log means exponent. Okay? And so let's go back and say, okay, so I'm going to take the log base 5 of the top one, which is 1, minus log base 5 of the bottom one, the denominator, which is 3, and then that's it. That's all we're doing. Now, yes, somebody said, hey, mister, can't we simplify this? Yes, if you put this answer, I'm happy with that. But if you think about this, what exponent of 5 gives me 1? What exponent of 5 gives me 1? Well, what exponent of anything gives you 1? 0, right? A 0 power. So this is saying 5 to the 0 gives me 1. So we can say this is 0 minus log base 5 of 3, or negative log base 5 of 3. If you wanted to, you could have kept it like this, and that would be perfectly fine, because all it asks you to do is expand. But the result of this log, if we evaluated that log, is 0. Because again, logs are asking what exponent of that base gives me that answer. And the answer is 0, because 5 to the 0 power will give me 1. And so that would be your simplified answer. All right. Are there any questions on the product property or the quotient property? If you haven't been here this week, I can't do the entire lesson again. The videos are up in Schoology. And again, where do I find that, mister? Go to our course. And then it opens up to materials. Go to week 20. And you'll see the last 2 days' videos. And then you can go to week 19, which was last week, and look at the introduction video, Introduction to Logarithms. And if you haven't been here the whole quarter, you know who you are. There's all the weeks. So you got a lot of work to do. Which, Again, you still haven't answered me. So, I mean, you still haven't responded to my. So that tells me a lot. All right. Any questions on quotient or product? All right. Let's go to the power property. So this is a nice property, and this is one of the main reasons we use logs instead of exponents, because some people are like, Mister, if logs are exponents, why do we have to complicate things, Mister? Why do we have to make it complicated? Why can't we just use exponents? Well, there's sometimes when you're using exponents and you have an unknown exponent, you want to work with them, and you can't set up an equation the way you like that's solvable. So if you organize it in a way where you can break stuff up and put stuff apart, it makes your life a little easier when you're trying to solve more complicated exponential problems. Okay, and that's what logarithms is for. Like I told you, math is discovered, and there is some math that's invented based on patterns and what's going on, and maybe looking at it from a different angle or different perspective. And so here's what we're talking about. So now we're taking a log of a result that also has an exponent, right? So now this is kind of an exponent within an exponent. This is asking what exponent of that base gives me this result that also has an exponent. Does that make sense? And you may have an unknown in one or more of these places. And if you just put it exponentially, like if we put this set equal to x and then we say, okay, b to the x equals m to the n, we have like 4 different variables here. Right? And it gets really complicated. So is there an easier way to do this? Well, yes. So here's what we do. Here's a nice thing we can do. If I'm taking the log of a result that has an exponent, this exponent can just be put to the front. And I think I gave that sneak peek to you guys yesterday. So this would equal, just get that exponent, put that in the front, and now we have log base b of m. Okay, so if you have a result that has an exponent, you can just get that exponent and just drop it in the front of the log. And then now you can just work with this and not have to deal with that exponent. And so it makes your life a little easier. Okay. And again, we're going to either expand or condense. Expanding means I have this and I'm going to go to this. Condensing means I'm going to go from this backwards to this. So that means if I have a number in front of the log, I can just get that number and put it right here as an exponent of my result. It goes either way. Okay, so what do I mean by that? Well, let's try one. Let's condense. So if you look at this, I have a 5 in front of log base 4 of 2. So guess what I can do with that 5? I can put it back right here. And this can be log base 4 of 2 to the 5th. Okay. Or I can keep going. Log base 4 of 2 times 2 times 2 times 2 times 2, which is 32. And if I wanted to solve this, if I wanted to, not solve, but if I wanted to evaluate this and get an actual answer, remember how we do that? So if you were just condensing, I'm done right here. I'm done right here. That's also an acceptable answer. These are 2 acceptable answers. But the instructions do say simplify if possible. So if I were going to simplify this, here's what I would do. I would say, okay, I don't know what this simplifies to, so I say it equals to x. I don't know what this simplifies to, but that equals to x. And so what I would do is I'd say 4 to this power gives me that result, right? That's what log means. What exponent of 4 gives me 32? And so I change it to an exponential. So that's how we evaluate logs. We change it to an exponential and we try to solve if we can. So 4 to the x equals 32. And the way we solve these problems is we have to simplify each side so it has the same base. And if we look here, that's a 4, and that's a 32. Oops, that's a 32. So can I change 4 and 32 to a base that's something different than 4 and 32, but the same on each side? Let me show you what I mean. Like, isn't 4 the same thing as 2 squared? And then that's to the x. So I changed 4 to 2 squared. And we just saw that 32, isn't 32 the same thing as 2 to the 5th? Yeah, that's 2 to the 5th. And so if I simplify this, this is 2 to the 2x equals 2 to the 5th. And now once I have the bases the same, I can drop these bases and just say, okay, that exponent equals that exponent. So 2x equals 5. And then divide both sides by 2. And so x equals 5 over 2, which means that this simplifies to 5 over 2, right? The question, again, logs ask the question, what exponent of 4 gives me the result of 32? And the answer is 5/2. 4 to the 5/2 power gives me 32. Mister, are we going to have to know how to simplify? Yeah. So once you look here, sometimes these logs are not simplifiable. Sometimes you just have to leave it like this and you're done. How do you know if they're simplifiable? You got to know your numbers. You got to have some type of number sense, and you got to know your numbers and look, okay, and say, okay, 4 is 2 squared. And 32 is 2 to the 5th. So that they both are 2 to the something power. So that means I can solve this. So let me change this to an exponential. So 4 to what power gives me 32? 4 to what power gives me 32? Well, change that to 2 squared. Change that to 2 to the 5th. And you notice they both have the same base. Once you know they have the same base, then we know we can drop those bases and just set the exponents equal to each other and find out the result. Okay, I'll give you a second to copy that. Okay, so I want you to try that one. I see in the chat someone said OMG. Why? Because it's a fraction? It's not as hard as you think. Just because you see a fraction doesn't mean it's completely complicated. I'll give you a minute to do this. It's not that complicated. How would we condense this? Well, we follow the rule. We get this number that's in front of the log and we put it right here. That's it. Log base 8 to the 1/3. Now, can we simplify that? Can we simplify that? What is 8 to the 1/3? So in your brain, right? In your brain, what is 8 to the 1/3? Well, if you remember, well, let's see. Do you remember? What is 8 to the 1/3? What does that mean? Hello? Am I on mute?
Bueller.
No, 8 to the 1/3 does not mean 8 to the 3rd, right? 8 to the 3rd is 8 to the 3rd. 3 and 1/3 are not the same. So no, it's okay. Good guess. Square rooted, careful. Square root means it's not a square root. It is a root though. Now, if you left it like this, okay, but what did the directions say? Simplify if possible. So 8 to the 1/3 can be simplified. Reciprocal, no, negative exponent means reciprocal. A negative exponent means reciprocal. So Darth Vader, what do you say? Is that the right answer? So it doesn't mean reciprocal. It doesn't mean square root. But you're on the right track when you said square root. It is a, come on guys, cube root. Yes, it's a cube root.
Oh, yeah.
It's a cube root. Yes, I got some new sound effects, those of you asking. It's the cube root, right? The bottom number is the index, and the top number is the exponent, right? So this is just the cube root of 8. And what's the cube root of 8? What's the cube root of 8? Come on, people. Yes.
Oh, no.
It is 2.
Oh, yeah.
Yes, it's 2. So this is log of 2. That 8 to the 1/3 simplifies to 2. And we're done. Because when you don't see a number here in the base, guys, what number's there? When you don't see a number there, what number is actually there? 10. Very good.
That's amazing.
Yes, it's a 10. That's it. So yeah, the hardest part was 8 to the 1/3 for you guys to remember that 8 to the 1/3 just means the cube root of 8, which is 2. And that's it. And we can't simplify anymore because if I wanted to solve this, this is asking what exponent of 10 gives me 2. And if I broke down 10 and I broke down 2, I wouldn't get the same base. So we just keep it like this. All right. Okay, let's do it the other way now. Let's expand it like this one right here. This one's really easy, right? All we do is we get this exponent and we put it in the front. So that becomes 7 log 2 of 8. Yeah? So now we're getting the exponent that's in the result and we're putting it in the front. We're expanding. So now we're just putting it in the front. Oh, wow. We are way over time. We are way over time. I'm so sorry. We will continue this tomorrow, guys. We are 5 minutes over time. I'm so sorry, guys. Don't want to make you late to your next class. Sorry about that. Let me know if you have any questions on Schoology. Take care and have a great day, guys. Sorry.